Welcome. Let's construct the polynomial where the degree is 3. That's what n equals 3 tells us. Where we have these zeros, -4 and -2 minus 5i, and where the function at -2 is equal to 150. With that information, we will be able to construct this. So first, let's recognize that that's going to be x plus 4. This one is going to be x minus, because that's x minus a -4, of course. X minus -4. This will be x minus the -2 minus 5i, but I won't go do further yet. But then we also have to do the conjugate. And the conjugate, for the conjugate, we only change the sign of the imaginary part of the number. So that means it'll be x minus -2 plus 5i. Because this part, this is the conjugate with only the imaginary number as the change part there. All right. Now, we know that the function of x is going to be equal to a, and a major part of our goal now is going to be to find that a, or solve for that a. That's why we're given this part over here, is so we can solve for the a. X plus 4, x minus -2 minus 5i, x minus -2 plus 5i. All right, now the next step, we're going to actually do the inside parentheses part there. So the function of x is equal to a, x plus 4, x plus 2 plus 5i. So we're going to distribute that to both. And this is one of the places people tend to make errors because they sometimes just don't finish the distribution and they don't change the signs of both things that they're supposed to. That's going to be minus 5i. Now that we've done that, we're going to do something that people aren't used to. But watch what I do and think about why I'm doing it here. X plus 2 plus 5i. X plus 2 minus 5i. So now let's analyze what I did here in these steps. I have x plus 2, and I have x plus 2 again. Notice that it's plus 5i and it's minus 5i. So if you think about this, let's call x plus 2 a and 5i b. I have a plus b, and here I have a minus b. Which means now I can multiply these out and get rid of the imaginary number. But I'm going to multiply them out by using x plus 2 as a and x minus and the 5i as plus or minus b. All right, so let's actually show this. So the function of x is equal to a, x plus 4. So I'm going to do x plus 2 times x plus 2 squared. So I'm going to do this times this. And I'm also going to do this. So it's -5i x plus 2. And then this times this. So it's plus 5i x plus 2. And then it's -25i squared. So notice that this one, that's minus this and plus this. So these cancel out. They're gone. They are no longer needed and they are gone. So to show it cleanly, I have x plus 2 squared minus, now I could do 5i squared still, and I guess I'll do that just to show that right now what I have here is I have a squared minus b squared. So by setting it up here as an a plus b, let's do a star better than that, to have it an a plus b and an a minus b combination allows us then to end up with an a squared minus b squared, and as a result, the i's will go away. let's mathematically do that next. Here, in this case, we have 25i squared. I squared equals -1. Since that's -1, we have a -25. Oh, and at this point, I'll also multiply out the x plus 2 squared. So it's x squared plus 4x plus 4. Now here I have minus -25 because this I squared will apply to the 25 as a -1. And so this part here becomes -25, but there's a minus in front of it, which means it's minus and minus to add it. So this is going to become a plus 25. So now we have f of x is equal to a, x plus 4, x squared plus 4x, 4 plus 25 is 29. Okay. Now at this point, I might as well just continue with the multiplying. X times x, we get an x cubed. Okay. And then we have 4x squared, another 4x squared, so we're going to get plus 8x squared. And then we're going to get 45x because of the, let's see, it's going to be 29. Oh, is there a minus in one of these? No. So 29x and 16x, 45x actually. Let's do this. X times x is x squared. Here we have 4x squared and 4x squared. Okay. So then we have 16x, right? And 29x. So 16x and 29x is going to be 45x. And then 4 times 29 is 116. Oops. There, got that weird thing away. So now that we're at this point, we have multiplied it in and out as much as we can. We have a as a missing variable, and this is where we use that other part. You go back up here, and now we're going to use that at -2, the result is 150. So since f -2 is 150, meaning that if we graphed it at -2, we would have a point at y is 150. So that means the result is 150 when we put -2 in for the x. And now it's a matter of figuring out these numbers, and this is just calculation at this point. If the pen here will cooperate. So I have a -8. That's 4 times 8, so that's plus 32. This would be minus 90 plus the 116. So 150 is equal to 50 times a, because all of that adds up to 50. Well, that means that a is equal to 3. All we now have to do with that 3 is put it in here. Oh, stop going away, things. Let's get it. So I have a nice straight, right in there, we put the 3, and then we're going to multiply it out. So I'm going to do that now. F of x is equal, if I have a 3 in here, if this is 3, then that means it's going to be 3 times x squared, or x cubed rather, plus 24x squared, plus 135x, plus 348. And that's for multiplying this 3 into each one of those numbers now. Into here, 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 and here. So I multiply each one of them. And it gives us the final polynomial of this. So if we were to solve this in normal ways, we would get that 4 I believe it was 4, wasn't it? Yeah, we would get a -4. That would get it down to a quadratic, and then we would use the quadratic formula, and we would get the two complex numbers. And we would also know that at the x of -2, we would get a y result of 150. Now, the key to this whole thing is back up here. It's all of this to recognize what you're doing. So this is where, even though you have learned that a plus b times a minus b is an a squared minus a b squared, you haven't seen it used like this very often. Now you have seen it, and it is part of a mathematician's like bag of tricks to recognize that they can adjust, move, and change things to put it into a style or a way of looking at it that they can then use something they know. And that's what we did here. Right? We used a plus b and a minus b, but we had to adjust it by associating the a plus b. We had to associate the x plus 2's in parentheses and call them a. All right, so hopefully that helps to understand what to do really when you have this kind of one of the zeros is a complex number like this. Not just an imaginary number, because if it's just the imaginary part, then that's relatively easy. You just use the opposite of that for the conjugate. But here you use only part of it where it becomes plus right here in this one. And then you have to adjust how you do your a plus b and a minus b. Thank you for listening. I hope that helps.